Alright, so today I would like to go over ggez, which is a game framework for Rust that is based on or highly inspired by Love or Love 2D, which is a game framework in Lua. And the reason why I want to do that is because I've been spending a lot of time in Lua writing Love stuff, and I want to try to transfer that knowledge from Love and Lua to ggez and Rust. So yeah, today we're going to be building a keylogger with sort of sliding text. It's kind of cool. I'll show it off in a second. Alright, so first let me show off what we're building because I already wrote it for the most part. The source code is here, and I'll put this link in the description. More or less, we're going to try to mimic this, but it's not going to be exactly the same because we're just going to write it from scratch. And let me run it real quick. And this could take a while. This computer isn't the fastest. Well, look, it's up. All right. So it says please type something, and then when you type something, the text gets removed, right? And it's logging our keys, our keystrokes. One thing that's sort of cool about this is that I have a character limit that you can see. So when I start typing a lot more things, you can see that the text sort of scrolls through. Also, the code is, the color is changing. And here you can see the frames per second rate, which we don't really need, but it's here. Anyway, we're going to try to do this from scratch. That being said, let's start the usual way and start defining things. So let's start with ggez. It's ggez. However, there's a rapper called ggez, and that always just flows off the tongue easily for me. So I may pronounce ggez as geezy over and over and over in the video. I am sorry about that. Alright, so if you get to the crates.io page for ggez, they have a description of what is this. ggez is a Rust library to create a good game easily, hence the name, ggez. Makes sense. More specifically, ggez is a lightweight cross-platform game framework for making 2D games with minimum friction. It aims to implement an API based on a Rustified version of the Love game framework. Alright, so the takeaways from those two sentences, let's look at the first one first. Cross-platform game framework, meaning that your game should run on a number of different platforms. Like you can build it on one and run it on another one, given that it's supported. And then two, they mentioned the Love game framework. The Love game framework is a well-known game framework, and they have a link to it here. We write 2D games in Lua, and it's pretty awesome. The wiki is pretty explanatory, nice documentation. I'm loving learning it. Let's go back to ggez. So starting from here, this means it contains basic and portable 2D drawing, sound, resource loading, and event handling, but finer details and performance characteristics may be different than Love. So in this sentence, they're describing what are the similarities and differences between Love, and they're going over some of the generic features of it. So portable 2D drawing, so you can draw things. You can add sound to things. You can load your resources, and it has event handling. But they're going to be different just because Love and Lua and Rust are very different languages. So the second paragraph here goes over some of the generics in terms of perspective when you're looking at ggez. So this is a base, and it's fairly batteries included in terms of things you may need to build a game, but it does not have everything. So it is not for everybody. Some examples are it doesn't include a physics engine or an entity component system. However, if you know what those things are or want those things, or want those things, you could probably either build them yourself or use other crates to supplement that need. So moving down, we have supported platforms. So I said earlier in the first paragraph that this is cross-platform. Fully supported platforms include Windows and Linux. Not officially supported but might work anyway, Mac and iOS. Works in progress, WebAssembly. Not officially supported yet, but maybe you can help, Android. So as of today of this video, Windows and Linux fully supported, Mac probably works, and everything else is in progress or with hopes to be, a future goal. Cool. So one thing that is really cool about this documentation, at least the Crazcalm.io page, is that if you scroll down to getting started, they have a bunch of docs, but they have examples, and these examples are pivotal in learning how to use this framework. The examples go over a lot. And if you want to run the examples, they have example of how to run the examples. Mainly, you clone the main library on GitHub, ggez, and then in their examples directory, they have a bunch of them, and you can just say the name there and then run it, right? But outside of that, one thing I really love about this documentation is that it comes with a basic project template. So if you want to get started with your game, here's the basic layout that you're going to have, at least starting out, while you're getting used to the framework. I'm going to copy this into a project, and we're going to start from there. So I'm going to do that, and then I'll get back to y'all. All right, so I finished copying over the template into a directory. I just called it ggez keylogger tutorial. Just to get a quick sense of what's here. Cat cargo toml. You can see right here that I added the ggez dependency, and then if we do stem source main, we can see that I just more or less just pasted the stuff in here. Let's run this real quick just to see what it gives us, and then I can go through the source code as is. So if we run this, you get a window that is all white, and at the top it says an easy, good game. That is it, that is all. So let's go to the source code real quick to see why that is. And I think that might be too big. Good enough. This chair is loud. Alright, so starting from the top, we do import. We have ggez event self, as in import event, and event handler. We have ggez import graphics context builder game result. Okay, they started off with this main loop. I'm not sure if that's the best way to start off in terms of reading this, so I'm gonna go through everything else, then I'll go back to the main loop. So they have a struct called my game, and then your state will go here. And then for the struct, they implement a new for it, where you just create struct, and here they say load/create resources such as images here. So before your game is, before the struct is initialized, create those stuff there, and then associate it with the struct, and that will be your quote-unquote state. They have event handler, which is a trait, and this trait has many things on it, but there are two things that you must implement yourself, and that is update and draw. So update, given that this is a game, there's going to be a game loop where you're going to have to update on frame to frame, update what things are like the positions and whatnot. And then draw is something that also happens post update. So after each update, you redraw everything to the screen. And you can see that here, where they have graphics clear, context, and white. They make everything white, and that's where we got the white background. And then to actually draw the stuff to screen, where they say draw code here, this is what presents it to the screen. And this is when we get to actually see the white hit the screen. All right, so let's go back to main. So in main, they have a context builder, new, and they pass in the name they gave it, and the author's name, right? They build, and if it fails, they have an error. This is going to give you the context that you're going to pass around everywhere in the event loop that's going to be running. And when I mean context is going to be passed around everywhere, if we scroll back down and look at the event handler, we see that there is a context that is always being passed through here and here. Scrolling back up to the top. Create an instance of your event handler. Usually you should provide it with the context object to use when setting up your game. So here they have my game new and they pass in a context. And like they were saying, they usually use that to help set up your game. We don't actually use that here, and that is passed in, but it's not used here. But they note that that's probably what you want to do. And then we have the running of the event loop, which they just did in a match statement. So the event loop seemingly just has a result where it's okay or there's an error. That is it. And this is where the game starts to run. So this gives us, let me go to the other screen. Cargo run gives us this. This is the result. So now we're going to work through just manipulating it. So first let's change the background, because I don't really like a white background. I'd rather have a black one. And try to put some text to screen. Cool. So I do find this text a little bit big. I'm going to make that smaller. So for background, that's something we already covered. So graphics clear, graphics white is what we're changing it to, right? So let's just change this to, I believe black is an option. And we're going to see exactly what the color stroke looks like a little bit later, but for right now I just want to change it to black, because I think the text by default, the color is white, and white on white doesn't show up really well. And we see now that the background is black. So let's look up how to do text. Okay, so for text to screen, one thing we're going to look at is the ggez examples. And example number 2 has a hello world, right? So we scroll down here to hello world. They have changed the main state to add some assets, which is they have a font, which they're loading a new font. So they're not using the font that's default. And then they're giving it some text, font, and seemingly a size. And then they're adding that to their main state. So they have frames, which I'm guessing is frames per second, and they have the text here. So frames per second we don't really care about at this point in time, but we do care about the text. So we're going to do that. Also, you can see that this is now returning an OK S, which is S is for main state, which means here we see that this is now, the main state is now wrapped in a game result. And game result, at least for ggez, is just an alias to a result type. So if we scroll down to their main to see what changed here, more or less it looks like they have a path now called resources. Oh, that is where the font file is located. So if we scroll back up, right, we see that they're going to slash blah 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 .ttf. And let me duplicate this so I can show you where that is. Examples, ggez. So this is their main repo, and they have a directory called resources, and in here, I believe it was this one. This is the TTF file that they're loading. So going back to the hello world, they're doing two things here. They're mounting that resource directory so they can access it. And then here they're saying add resource directory. And then in the main, they're loading it here. And I think they do one more thing. So in the draw, they have a different clear, which is fine. They have here, which is frames per second, which we're not going to really mess with right now. But from here, they have a destination point. So for game programming in general, or putting things onto the screen, you need to have a location of where you want to place something. And they use mint, point to, point just 2 being just 2-dimensional point. So you have X and Y. And then they do graphics draw, context, self.text, destination point, and then they present that to the screen. And I think that got changed to a question mark, because I think this is now returning a game result. But yeah, we're going to work on doing that first. So let me write up that code and we can walk through it. Alright, so I've made the updates to the code so that we can display text on the screen. So let's go through that real quick. In terms of the imports, I've added 2, and I'll go over them as we see them. But the first one is standard library path and ggez mint, right? So going to the main, we saw in the example that they loaded a resource directory so that they could just sort of find all the resources there and put them there, store them there, right? So I created a resource directory and I loaded it, called it resources here. And then on the event loop, or the context builder, when we're building everything, we use the method add resource path, and then we put resources there so that the game knows that that is something they can look for in terms of resources, a search path. Other things to note in terms of changes, I made main return a result, which sort of simplified things along the way. As you can see, the event run no longer has the match statement that just checked for OK and error. That gets returned directly, so that's no longer here. And my game, in the example, they changed the new function to return a game result, and because it's returning a game result, now I can just use the question mark if there's an error. So coming down to my game, earlier it said put your state here. Our state is going to be our text, and thus we have a new field called text, and it's going to be graphics text. So graphics text is what ggez writes to the screen. So going down to the new, earlier we saw that they had a load/create resources such as images here. The example for the hello world also had another comment stating that the TTF file will be in their resource directory, and it was a little longer than this, but more or less we mounted the directory so that we can omit the path here. So seemingly, if you wanted to, you can have the absolute path to the TTF file here, and that should probably work. I am not sure, but the easiest way to go about this is to mount the resource directory like we did above. Well, graphics font new is how you add a new font, and you pass in the context. The context is what we were passing around throughout the game. To add new text, we did the text, the font, and seemingly the size of the font, which is okay, cool. And then we created a new game, add text to it, and then we return that. So in terms of draw, update hasn't been changed at all because we're not updating anything yet, but the draw has been changed. So we created a destination point, and like I was saying earlier, when you have a graphical interface, you have to pick the point on that graphical interface where you want to place your item, and the items are drawn from the top left corner all the way out, right? ggez re-exports a algebra library, so let me go find that real quick. It's called mint. So mint, as it's stated here, is a math interoperability standard types. As in, they have standard math types that you can use that can seemingly be used in many different places. And it's very useful in computer graphics. And point 2 is just a point in a 2-dimensional space. And that's why it has X, Y fields. So there's no new on this, and we're just instantiating the struct directly. But yeah, that's more or less what this is. This is just a helper class. So make this big. So we're creating a point. We're giving an X and Y. And then we're saying graphics draw context. So we know what you're drawing on, or what you're using. We're going to take the text from the mygame.text, and then we're passing this tuple that has destination point. And then everything else is the same, presented to screen. And to show you what that looks like, run it real quick. We now have an easy, good game, Hello World, right here on the top left. And I did the offsets by 10, so it's not all the way in the top left, but yeah. That's what we have so far. So next, we're going to work on changing the text. So having key inputs manipulated. All right, so I made the change to update the text. So let's go to documentation before I go over it, just so we can see where I got this stuff from. And documentation is here. So if you go to ggez and you look at the event handler, right? The event handler had the required methods of update and draw, which we touched upon. But they also have a bunch of provided methods that you can override. And this is how you do all of your interactions more or less with the user. You have the mouse button down event, mouse button up event, mouse motion event, keyboard down, keyboard up, and the one we're going to use today is text input event. So the text input event is a Unicode character was received, usually from keyboard input. This is intended a way of facilitating text input. So as soon as the user types something, that character is passed in through here, and then once we have the new character, we can update the text. And in terms of the text, I went to the text documentation. So if you go to ggez graphics text, you can scroll down and you'll find that a drawable text object is essentially a list of text fragments and some cast size information. So a text object is more or less a text fragment. And if you want to manipulate those fragments, you can see here they have a fragment manipulate. And if we click on test fragments, which I think I did, so text fragments consist of 4 fields, 1, 2, 3, 4. One is the text, one is the color, one is the font, and one is the scale. So we want to change the text, which means that we can use this method, fragments mute, and then just access the text field and change it to something new. So that's what we did. So going over to the source code, in the event handler, we added the, where's my key? Here it is. We added the text input event, which takes an immutable self, a context, which we're not using, and a character, right? Then we said self.text.fragments mute, and we went to the first item in the list, because if we look at the documentation again, it comes back as a vector, so a list. We called the .text field, and then we changed it to what it's going to be now, which is the character, and we made the character to a string because text is a string. And when that is done, this is what the results look like. So cargo run. We have hello world as the standard, and then when we start typing, we see that the text disappears, and it gets replaced with whatever we type. All right, now that we have this, we want to move on to the next section, which is keeping track of all of the characters that we have seen so far in a list and making sure we only display a certain amount of them onto the screen. So it looks like we can keep, let's say 10 characters. And once you put the 11th character in, the first character gets popped off, and then we still only see 10 characters. So building that out. And I'm going to do that, and then I can get back to you. All right, so I added the piece that allows us to sort of store the characters up to a certain limit and then display those to the screen. And I put most of that code into a new file. So let's go over that first, just so we understand the concept of it. Then I'll show you how I modified main, and then we can run it to see where we're at. So I created a file called logbuff, which is just a logging buffer. And let's open that real quick. So logging buffer is a struct that has a usize and a stack that's going to be just a vector of strings. So the size is going to denote how large or how many characters we should store, and the stack is where everything's going to be held. So we have implementation, we have new. The reason why all of this is public is because when I did mod log buff in the main file, it required everything to be public. So everything is public. Scrolling downward, we have the initialization of log buff, which already told you what that entails. But we have 3 methods on it, right? We have a add method, as in we're going to take an input and add it to the stack. And we saw that in the main function where we gather the text, they come in as characters. So here we're going to take in a character as well, and then we're going to add that to the stack. So before we add that to the stack, first we check to see if the stack is the appropriate length. So if the stack length is greater than or equal to the size that we required it to be, then we're going to remove the first item from the stack. And this is the syntax for it, the stack remove. And then you pass in the index, which is the first item, 0. And then after that, we're just going to add the new character that's coming in to the stack. So we're pushing that to the stack, and we're converting it to a string. Another thing I have here is delete. So the reason why I have delete is because when we hit the backspace key, I want to be able to remove a character so it's no longer being seen. And the proper way of doing that, at least the way I went about doing that, is I check to see if the stack length is greater than 0. And if it is, then I pop the last item from the stack. And I have an expect here for error handling purposes, but it shouldn't really fail. And then lastly, I have a function called getText, which formats takes the stack and then translates it into a string that we can just pass straight to the graphical text or self.txt and put that to the screen. So here I have create a new string, and then I iterate over everything in the stack, and I just push that to this new string, and then I return the string. And for my sanity purposes, I have some tests here, which you feel free to go over. They're in the online repo as well. But more or less, coming back to log buff, which isn't long, you have a stack, you're putting items in, and you're displaying those to the screen. And you make sure the stack stays a certain length. Right? So let's exit here. And now let me show you how I changed main. So in main, I did a couple things. In terms of inputs, I added ggez input keyboard key code, mainly so that I could check to see if the backspace key is pressed and then delete on that. And then here's the mod log buff, which I added, and then I'm using it here. So if we come to the, where is it? It's in the event handler. Here we go. All right, so all the changes happen in text input event. And like I was saying earlier, I'm checking to see if the keyboard has the backspace pressed so we can delete a character. And one way to go about doing that is just to check explicitly using ggez input keyboard is key pressed, and then passing the context and the keys. So earlier I showed the import of key code, and key code back is the one for the backspace. And if I were to delete this and come down here so you can see the documentation, it says the backspace key right over enter. If the backspace key is pressed, then I want to delete from the buffer. Else I want to add the character to the buffer. And then after the buffer has been changed, we have the same line we had before when we modified the fragments for the text, but now we're changing it to, we're modifying it to log buff get text. And all this together results in this. So hello world is the initial text, right? And then if we start typing, we can see hello, I can delete things, hi, how are you? And we now see that the text is scrolling. Cool. So we got to this point where we have scrolling text. So there's seemingly only two things left to do. One, make the text color change, because I like changing the color. And then two, trying to get that to the center of this window. So let's do the color changing first. I'm going to write it out and then we'll go over it. Alright, so in order to do the color first, let's look at the color documentation, and that is here. So ggez graphics color. And we have the standard RGB, which is red, green, and blue. And then we have A for an alpha channel, which is, I believe, transparency. One thing to note is that by default, the range that you put in for the RGB and the alpha, ooh, didn't mean to do that, is from 0 to 1. They are float 32s, right? However, if you have a different range that you would like to use, it looks like you can do that. You can go through the methods here. They have like a from that incorporates numbers from 0 to 255. So that's a thing. But we're just going to use the regular float. And in order to create a random number, I use the ran crate. I just added it to the TOML file. But let's look at the code real quick. So in terms of the code, I added a new file called utils, and that's why I put the random color function. So let's look at that real quick. So for the random color function, I import graphics, because graphics is where color lives, and I import random and use that. And more or less, I'm using the random number generator to generate numbers between 0 and 1 that are float 32s, and I'm using that to create a color, and I'm returning that color. And in terms of the main file, let me open that to show you where the changes were made. All the changes occurred right here, seemingly. So in the event handler, we have the text input event, and we noted earlier that the text has a thing called fragments mutable that we can get access to and just change some of the features on it. So I decided to do that here. And in fragments mutable, they have a dot color. This color is an option, so the random color that I create has to be wrapped in a sum. And let me show you what that looks like. This might take a little while to build. So we have hello world, right? And now if we start typing hello world, this is me. We can still delete and all that other stuff. Alright, so we've accomplished the task of writing text to screen, having it log a certain number of keys, and changing colors. Now we want to try to move it to center. So I'm going to work on doing that, and then I'll share how I did it. Alright, so I went about moving the text to the center of the screen. And to see how I did that, let's go to the draw. So in order to move text to the middle of the screen, I have to first figure out the size of the window. And the way I went about doing that, and I'm not sure if this is the right way or the only way, but the way I went about doing it is ggez graphics window, and then on it I called get inner size. And let me go to that documentation real quick, just so you know why I'm hesitant to say this is the right way. So in the documentation, ggez graphics window says this call returns a reference to the gluten window. Ideally, you should not need to use this because ggez will provide all of the functions you need without having to dip into gluten itself. But life isn't always ideal. So hopefully, there's probably another way of going about doing this. However, I do not know it as of right now. And then if you click on the window to go to that documentation, they have different ways of trying to get sizing. And I use get inner size, right? And get inner size returns the logical size of the Windows client area. The client area is the content of the window, excluding the title bar and borders. So yeah, I thought that would work. And logical size, which they have here, is represented with the fields width and height. And they are float 64, so they have to be converted. Cool. So going back to the source code, I do the window, get inner size, and do an expect because this is an option. And then for the text, now that I have the size of the window, I can divide that by half to get to the center of the window. But the text itself also has a size. The way I went about figuring that out is doing self.textWidth, which seemingly comes as a U32, but let's go to documentation just to verify that. Text, and then height and width. So we height and width come back as U32s, which is the wrong format, and I need to convert that. But more or less it says, returns the width of the formatted and wrapped text in screen coordinates. Ah, I see. It looks like we could have used dimensions as well. Understood. And the reason why I say we could have used dimension is because that gives it back in a tuple of width and height, that order, but I just called them individually. Anyway, going back to the source code. So we have the width of the screen, we're looking at X right now, width of the screen divided by 2, minus, so getting to the center of the screen, and then we have to offset it for the text size. So the width of the text also divided by 2, moving that over. And do the same thing for Y. And then we just modify the destination point to now take in the text X, text Y that we just defined here. And what that looks like when you run it is this. We have the hello world in the center, and when we start typing hello world, goodbye world, we can see that the text more or less stays in the center and it's just scrolling through the screen. There we go, that's a little bit brighter. One last thing to change, and that is the title bar, because this an easy good game is kind of annoying me right now. And then we're done. Alright, so I went through the documentation and I found where you set the window title, but I also found the proper way of getting the size of the window. So if we go to ggez graphics and we scroll down, look at the methods, right? They have one called set window title, is what we're going to use to set the window title. And that just takes the context and a string. But they also have one called size, which returns the size of the window in pixels as width and height, including borders, title bar, and return 0 if the window doesn't exist. So if we use size, we can take out the code that we're using earlier that used window directly and just refactor it. So putting those two things together, we get the following. Didn't mean to do that. So here's the main code. And then let me go to draw. So in terms of the window size, or sorry, in terms of the window title, in draw I just added a new call to it. Set window title, context, and then set the title as a string. And then the title, because it's going to be for the game, I added that to the game struct, or my game struct. So we come all the way to the top, or right here. I add the title here, which is going to be a string. And then in the new, when we create a my game, I'm passing in a string, and then I'm owning it for my game, and then setting that as the title. And then if we go all the way up to main, here, when I create my game,
I'm passing in a title, which is now keylogger, and that should be the title that's going to be displayed at the top of the window. So going back to the draw, we can look at how we change that window call to ggez graphic size. One thing to note is that the size is currently a F32, so it doesn't have to be converted or anything like that. And it's a tuple, where the first item is the width and the second item is the height, which is down here. It got moved to another line for some reason. Don't know why. Oh, the formatter is doing that for me. Understood. Outside of that, everything else is more or less the same. So let's run this and see what the final result is. So we now have the title keylogger, which is there, and we have the hello world, with scrolling text. Alright, so that is more or less what I wanted to cover today. So in summary, what we did today was we used ggez to create a window or a small game where we can type, it captures the input, and we scroll that input across the screen while changing the color. If you like the video, hit like, subscribe, yada yada. Outside of that, till next time. Peace.